Before we jump right into new material, let's review things that we already know. First, we have the table of values, which is a list of numbers that have been substituted for a variable. In a table of values, there are two variables: the independent variable, which is located on the left side of the table, and the dependent variable, which is located on the right side of the table. The dependent variable relies on the independent variable for the numbers underneath it. However, the independent variable does not rely on anything. Equations are another way to show linear relationships. This equation shows that y is equal to 2x plus 1. What we have to do is substitute x in for a number. In this case, x is being substituted for 3. So the equation is now 2 times 3 plus 1, which equals 6 plus 1, which equals 7. That means that y equals 7. The final review material is the coordinate plane. The coordinate plane is made up of two number lines. The x-axis, or the horizontal axis, carries the supplied values, or the independent variable. The y-axis, or the vertical axis, carries the dependent variable, or the calculated values. There are 4 quadrants. The top right is the first, the top left is the second, the bottom left is the third, and the bottom right is the fourth. Always remember to arrowhead your axes and label them. When plotting points, the x-axis always comes first and the y-axis second. In this case, we're going positive 3 on the x-axis and positive 2 on the y-axis, making that point A. In a direct set of data, the x-axis will be 0 and the y-axis will be 0 for the first plotted point. To check if a data is direct in a table of values, the first 2 should be 0, making it a direct set of data. In a partial set of data, the first plotted point will be somewhere along the y-intercept, as long as it's not at 0. In a partial set of data's table of values, the first 2 values will not be the same. In a linear set of data, the line in the graph will be straight. Any graph with a curved line has a nonlinear relationship. We use the first difference of the y value to see if a relationship is linear or nonlinear. The first difference is the difference between each y value. In this case, the first difference is positive 5. Since all y values are going up by 5 each time, this is a linear relationship. If the first differences are different, it is a nonlinear relationship. Slope is the steepness of a line segment. To calculate slope, we use m equals rise over run. To find the slope, you can draw a little triangle to make it easier to see the rise and the run. In this case, 2 and 2. In this case, the equation is now m of AB equals 2 over 2, which equals 1. Lastly, we have y equals mx plus b. This equation is a method to graph line segments. Here is an example that states that y equals mx plus b and y equals 4 over 2x plus 3. Y represents the y value, 4 over 2 represents the slope, x represents the x value, and plus 3 represents the beginning point. First, we're going to use our beginning point of 3 on the y-axis. Then, we're going to use our slope with our rise of 4 and our run of 2. Now we're going to continue our line segment. Now we have successfully graphed a line. And that concludes my study guide for linear relations. I hope that you enjoyed and found it helpful. Thank you.